Welcome to the sign of a function. The initial concepts will be a bit of a recap of things we did in Year 11, and then we'll move on to looking at the curve and how it operates above and below the x-axis. So we did look at interval notation for inequalities, and we're just going to add to that with the union of intervals. So where we've got opposite ends and how we write that as an inequality and then as a interval notation. So obviously to the left of 3 and it's equal to x is less than or equal to 3 and greater than 6 it's not equal to, so we just use the greater than sign. When we write it in interval notation, it goes to negative infinity up to and including 3. So the square bracket next to the 3. And union representing it also includes from 6 to infinity. We also looked at composite functions. We looked at the second style, the g of f of x, where the f of x was inside the brackets. But it can also be g with a little circle, g of f of x. And we're just going to recap this. So our example is if f of x equals x minus 4 and g of x equals x squared plus 2x, we're going to find all of these. Remember, we do the second part first. So we do, when it's the part A, g of f of 7, we do the f of 7 first, then we do the g of that. So here we go. F of x equals x minus 4 and g of x equals x squared plus 2x. And we're finding g of f of 7. So we start with f of 7, get a value for f of 7. Sub the 7 in for the x in the f function, and you get 3. Use this value to sub into the g function. So g of 3 is 3 squared plus 2 lots of 3. So g of f of 7 is 15. If we turn it around and make it f of g of 7, we take the 7 first and sub into the g first. So g of 7 is 7 squared plus 2 lots of 7, that's 63. Now sub that into the f function. So we get 63 minus 4 is 59. What about when we don't have values to sub in? We're just subbing the function into the other function. So in this case, g of f of x means we're going to take the f of x function and place that in the g function. So wherever there's an x in the g function, we're going to replace with x minus 4, because that's the f function. And so we get x minus 4 all squared plus 2 outside of x minus 4. When we expand our brackets, we get x squared minus 6x plus 8 after we collect like terms. So the alternate, subbing g of x into the f, so into the f function, wherever there's an x, we're going to replace it with x squared plus 2x. So we get x squared plus 2x minus 4. F of x, so now we're subbing f of x into itself. So we sub the x minus 4 in wherever there is an x in the f function, and we get x minus 4, which is x minus 8. And then looking at g of x, we sub the g function into the x where the g is for the g function, and you get x squared plus 2x all squared plus 2 outside of x squared plus 2x. When you expand that and collect like terms, you get x to the 4 plus 4x cubed plus 6x squared plus 4x. Now we're going to look at the sign of a function. So note, a function may change sign, so this is a graph, at a 0, so when it crosses the x-axis, so it could go from being above the x-axis, which would be positive y values, to below the x-axis, which would be negative y values, and at discontinuities. So we know that with a hyperbola, we could, on one side of the asymptote, we could be below the axis, and on the other side of the asymptote, we could be above the x-axis. So we're going to have a look at an example at how this works, and we're going to look at a table of values to solve questions. So we're going to look at x squared, x minus 2, x minus 4. as a function. So we're going to sketch that graph first. So we know that it's x values where it's the zeros are at 0, 2 and 4. And at x squared it bounces off and we sketch the graph. So it passes through at 2 and 4. It starts above the x-axis to the right of 4. It comes down, turns. This has been done from Desmos, so we don't need to, we will find out during this topic how to find where that point turns. But for the moment, just have it turn and then comes back up and passes through at 2, has to turn again, comes back, bounces off at 0 and goes back up. So if we look at this using values, so let's take a value to the left of 0, -1. We'll take the value of 0. We'll take a value between 0 and 2, which is 1. We'll take 2, a value between 2 and 4, which is 3. We'll take 4 and a value to the right of 4, which is 5. And if we sub the values into our equation, so let me start with -1. So we do -1 squared, which is 1, times -1 minus 2, which is -3, and then -1 minus 4 is -5. So 1 times -3 times -5 is plus 15. So you'll notice that your y value is 15, and the sign that goes with that is a plus because it's a positive value. The y value for 0 is 0. The y value for 1 is 3, so that's a plus. The y value for 2 is 0. The y value for 3 is -3, so that's a minus. The y value for 4 is 0, and the y value for 5 is 3. So these are going to be important because when we're discussing where does this curve, where is it greater than 0, that's going to be where the y values are positive, and where it's less than 0 are going to be where the y values are negative. So from our graph and from our table of values, where is y positive? So in our table of values, it's when x is less than 0, between 0 and 2, and when x is greater than 4. That's all our positive y values. So if we write it in interval notation, that's from -infinity to 0, 0 to 2, and 4 to infinity. Where is y negative? Well, from our table, that's between 2 and 4. So for our final section, greater than or equal to means where is it y positive and equal to 0. So we know that everything, where is it always above the x-axis, where is y positive, is x less than or equal to 2, because that's where the graph is above the axis, x-axis, and also equal to 0, or x greater than or equal to 4. So in interval notation, it's -infinity to 2 with a square bracket at 2, and the union with 4 to infinity with a square bracket at 4. Now, hopefully you won't need to draw a table every time, but if that's what helps, then that's what needs to happen. Now we're going to look at a hyperbola and how this operates. So obviously we'll end up with asymptotes and discontinuities, and we'll have a look at how we actually solve for where it's above or below an axis. So the first part is we're going to show that 1 plus 1 over x minus 4 equals x minus 3 over x minus 4. So start with the left-hand side, 1 plus 1 over x minus 4. Common denominator, so x minus 4 is the common denominator. And collect your like terms on top. So you get x minus 3 over x minus 4, which is the right-hand side. To help us graph, we find the x-intercept. That's when y equals 0. So you let 0 equal to x minus 3 over x minus 4. Obviously, if I times x minus 4 by 0, anything times 0 is 0. So I get x minus 3 equals 0, so x equals 3. If I wanted to find where across the y-axis, I'd let x equal 0, and we would get minus 3 over minus 4, which is 3/4. So here's our graph. Notice that it passes at 3 on the x-axis, as we talked about, and about 3/4 on the y-axis. You can see our asymptotes at x equals 4 and at y equals 1. So less than or equal to means where is y negative and equal to 0. Now, if you look at your graph, where is the y values negative? Where is the curve below the x-axis? And that's between 3 and 4. Now, it can equal to 3 because that's actually a point on the curve, but it can't equal to 4 because 4 is one of our asymptotes. So you've got to be careful in this case. So when we write that in interval notation, we write it's from 3 to 4, square bracket around 3 because it's equal to it, curve bracket around 4 because it's not equal to it. Thank you.